I'm going to do a mechanism for drawing Bernoulli's polyzonal curve. That's what the curve looks like there, and the mechanism. In actual fact, I'll end up having to do a couple of different versions of the mechanism just to get the whole curve coming out in GXWeb. As the mechanism itself is pretty straightforward. We're going to have a slider kind of on the x-axis joined to a slider there on the y-axis, and then we're going to have a line coming up and a perpendicular here. Like that, perpendicular. This length is A. This length is √2 times A. And we can move A, the point, backwards and forwards along the x-axis. We can parameterize that motion by parameter t. And then the point we want to trace is C, as t varies. And there's a little piece of the curve. We can change the parameters of t to give us more of the curve. Let's go from, say, -5 to 5. See what we get. So there's getting more of the curve, but you can see that, of course, it's not going to get over the top because we want a second solution coming around here to get the rest of the curve. To do that, we're actually going to need to put in another solution, we have to, in essence, take apart the mechanism and put it back together again. We'll do it in a second, but first of all, let's just take a look at what the equation of that curve is. Okay, so it's fourth order curve. Relatively simple equation. To construct the top part here, what I'm going to need to do is come up with another solution driven by A to these, another position to put these two links. So there's my two links. I'll give them the same length. Sorry. A and √2 times A. And then I need this point E to lie on this line here. And we'll follow that, we'll get that piece of the curve. So that gives us the whole curve, the whole top part of the curve. Let's just take a look at the equation of this top part. And we find it is indeed the same. To get the lower half of the curve, we would need to construct the mechanism again in a different way. I'll just take a piece of that coming from B now, another √t times A. And again, we'll put PF on this line. And follow it. And if we want the final piece of the curve, we'll connect up this line in this direction. This point, sorry, we put line of, again, √2 times A. And again, we'll position G on the line CA. And trace it. And so there we can see the entire mechanism. Now we can animate it like that.